Question 7, Part A. Question 7 is 70 markers, and believe it or not, this Part A here for drawing a triangle is 15 marks. And we're looking for the fourth pattern in this sequence. Pattern 1, pattern 2, pattern 3, and what's pattern 4? We look at pattern 1, there's 2 black triangles on the bottom. Here we have 3 black triangles. And in pattern 3 we have 3 plus 1 is 4 black triangles. So on pattern 4 I'm thinking there's going to be 1, 2, 3, 4 black triangles on the bottom. So that's the base of the first one, second, third, fourth. So triangle number 1, triangle number 2, triangle number 3, triangle number 4, 1, 2, 3, 4, oops, 1, 2, 3, 4, I need an extra one. And that's it. I'm started. So I have 5 black triangles on the base, and then the next level is going to start here, and I'm going to have 1, 2, 3, 4. Color them in. Like so, and on we go. 1, 2, 3. Great crash all together. And another one. Same idea again. And at the top. So that's pattern 4. 15 marks in the bag. Question 7, Part B. This one is worth 15 marks. And it's fairly straightforward. Pattern 1. Number of black triangles 3. 1, 2, 3. Number of white triangles 1. 1. Total triangles 4. So for pattern 2, we have 1, 2, 3, 4, 5, 6 black triangles, and the white triangles 1, 2, 3 of those, for a total of 9 triangles. For pattern 3, we have the same number again. You see, this is like pattern 2 here, this bit here, right? And that was black triangles 6, and with 3 more. 1, 2, no, 4 more. 1, 2, 3, 4. That gives us a total of 10. Let's double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 black. And we had 3 here, so we have 3 here plus 3 more white ones. 1, 2, 3, 4, 5, 6 white triangles. Gives a total of 16. Then in pattern 4, it's like pattern 3 with an extra row on the bottom, right? So we had 10 black triangles for the previous pattern. 1, 2, 3, 4, 5. So that brings us up to 15 black triangles. And the number of white triangles, well, we had 6 for the previous pattern, plus 1, that's 7, 8, 9, 10. For a total of 25 triangles. Now pattern 5, so what's the pattern? 3 to 6 is 4, 6 to 10, or 3 to 6 is 3, jump of 3, plus 4, plus 5, plus 6 will bring us to 21 black triangles. And the pattern here, we have a jump of 2, a jump of 3, a jump of 4, and a jump of 5 will bring us to 15. And then we add the 21 and the 15, and that will bring us up to a total here for pattern 5 of 36 triangles. 25 or 15 marks for that. Part C there show that the number of black triangles forms a quadratic sequence. So first of all, we'll write down the number of black triangles. 3 in pattern 1, 6 in pattern 2, and 10 in pattern 3, 15 and 21. And to show that they contain that they form a quadratic sequence, we'll get the difference between 3 and 6. 6 minus 3 is 3. And then we'll go for the next two. 10 minus 6 is 4. 15 minus 10 is 5. And 21 minus 15 is 6. So this row here, or this column here, 3, 4, 5, 6, that's known as the first difference. And you can see it's getting bigger by 1 each time. And now we're going to get the second difference. 4 minus 3 is 1. 5 minus 4 is also 1. And 6 minus 5 is 1. And this column here is known as the second difference. And we can see here that the second difference doesn't change. The second difference is constant. And that demonstrates that the numbers of black triangles in the patterns forms a quadratic sequence. D part 1, how many black triangles are in the 9th pattern? Well, we already know 1, 2, 3, 4, 5. The first 5 patterns contain 3, 6, 10, 15 and 21. And from 3 to 6, plus 3, plus 4, plus 5, plus 6, plus 7 will give us 28, plus 8 onto 28 will give us 36, 9 onto 36 will give us 45, that was a 9, and the next one's going to be 10, brings us up to 55. So that's pattern 1, 2, 3, 4, 5, 6, 7, 8, 9. Pattern 9 has 55 black triangles. Part 2, how many white triangles are in the 9th pattern? Similar process. We know the first 5 white, so we have 1, 3, 6, 10 and 15. And this time there's a jump of 2 to get from 1 to 3, then it's 3, then it's 4, 5, 6 onto 15 gives us 21, 7 onto 21 gives us 28. That was 7, so 8 onto 28 gives us 36. And then that was a jump of 8, and then a jump of 9 onto that gives us 45. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th pattern in white is 45 white triangles. So then it's a simple matter. How many small triangles in total are in the 9th pattern? Well, we just add them up. So T sub 9 there, 45 plus 55 gives us 100. Part E, write an expression in n for the total number of triangles in the nth pattern. So we're going to try and spot a pattern here and express it using little n's and numbers. Okay, so if we look at the total number of triangles that we got previously, we had 4, 9, 16, 25, 36. Right, so we can kind of look at those numbers and see if we can spot a pattern. Well, you see this one, these are all squared numbers is what stands out for me. Just 2 squared, 3 squared, 4 squared, 5 squared and 6 squared. So it's going to be something squared. And in the first case it's going to be 2 squared. In the second case it's going to be 3 squared. And where n is the nth pattern, like for the first pattern it's obviously going to be 2 squared, but n for the first pattern, n is going to equal 1. So what can we do with n to bring it up to 4, but we want to involve squaring it? So, you know, 1 plus 1 is 2. So n plus 1 squared, will that work? When n equals 1, 1 plus 1 squared, 2 squared is 4. When n equals 2, n plus 1 squared would equal 2 plus 1, which would be 3 squared, which is 9. And when n equals 3, the third pattern is a total of 16. When n equals 3, n plus 1 will equal 4, and 4 squared is 16. So n plus 1 squared is an expression in n for the total number of triangles in the nth pattern. Part F. The number of black triangles in the nth pattern is given by the formula here. B sub n equals a half n squared plus 3 over 2n plus c. Find the value of c. Now, 5 marks going for this. Well, now we know that the number of black triangles, say in pattern 1, so when n is 1, b sub 1 equals 3. That's the number of black triangles in pattern 1. So when n is 1, this whole formula here equates to 3. So we can write down n is equal, remember now, when n equals 1, b of n will equal 3. So we have a half n squared plus 3 over 2n plus c equals 3. And we can just sub in 1 there for n each time. So we have a half times 1 squared plus 3 over 2 times 1 plus c equals 3. And then we'll tidy that up a bit. That's just going to come to 1 times a half. So we'll have a half plus 3 over 2, or 3 halves, plus c equals 3. So 1 half and 3 halves is 4 halves. 4 over 2 plus c equals 3. And this simplifies. 2 divided into 4 gives us 2. So we have 2 plus c equals 3. So what's c going to be? C has to be 1. Okay, and you would have got 3 marks there if you substitute, if you put in 1 for n. Just there. 1 correct substitution into the formula would have got you 3 marks out of 5. Part G. Use your answers to parts E and F above to find a formula for the number of white triangles in the nth pattern. Well, we already have a formula that we got in part E for the total number of triangles, and that was the total number was n plus 1 all to be squared. So that's the total number of triangles. And we also got figured out or finished off the formula for the number of black triangles. So if we get the total number of triangles and we subtract the formula for the number of black triangles, which was a half n squared plus 3 over 2 times n plus 1. So that's the total minus the black, and that's equal to the number of white triangles. And that's essentially our answer, only we now need to tidy this up. So n plus 1 squared, n plus 1 times n plus 1 minus, so we'll stick in the minus here with minus n squared over 2 minus 3 over 2n minus 1. And we can further tidy that up by multiplying these brackets here. So I'm just running out of space, so I'll go down onto my white sheet here. N plus 1 times n plus 1. If I draw a wee line here, I have n times n plus 1 plus 1 times n plus 1. And I'm also going to have, still maintaining this stuff here, minus 3 over 2n minus 1. So this is n times n is n squared, n times 1 is plus n, and multiplying plus 1 by n I get plus n, and plus 1 by plus 1 I get plus 1. Minus n squared over 2 minus 3 over 2n minus 1. And tidying up a bit, I have n squared plus, adding these two together I get 2n. The plus 1 will cancel with the minus 1, so I'll have minus n squared over 2 minus 3n over 2. So this guy here is like 1n squared, and that's like minus a half n squared. So 1 minus a half leaves us with a half, so we'd have n squared over 2. And then we have 2n minus 3n over 3 over 2n. So that's like 1 and a half. 2 minus 1 and a half would leave us with a half, which would be n over 2. So now things are getting pretty tidy. And now finally we could sub out an n here, so we could have n times n over 2 plus 1 over 2. You're going to get a lot of marks there, maybe full marks much earlier than this, but we could also take out the 2 and we'd have n over 2 times n plus 1. And perhaps that's the tidiest way of presenting your answer. Part H, one particular pattern has a total of 625 triangles. Find the number of black triangles and the number of white triangles in that pattern. Well, first of all, if we can find out what pattern that is, what's the value of n? Is it the first, the second, and so on? So we already know we have a formula for the total number of triangles in terms of n plus 1 squared. In this case, equals 625. So we can figure out n, that'll be useful. So if we get the square root of both sides, n plus 1 squared, get the square root of that, we've just n plus 1 left, equals the square root of 625. Bang that into the calculator. The square root of 625 comes out at 25. So n plus 1 equals 25. We're going to subtract 1 from both sides, and we're left with n equals 25, take away 1, n equals 24. So now we know that it's the 24th pattern. And to find the number of black triangles, we're looking for the number of black triangles in the 24th pattern. So that's b sub 24. So we use our black triangle formula from earlier, and that's a half n squared plus 3 over 2n plus 1. But in this case, n is going to be 24. So we just put in 24 plus 3 over 2 times 24, like that, plus 1. Stick that all there into the calculator, and you will get, hopefully, 325. So that's the number of black triangles. And the total number of triangles was 625. 625. So 625 minus 325 equals 300. So that means we have 300 white triangles. And that's it for question 7.